Welcome back to Chemistry 12, Chapter 5, Lesson 3, Amines. The objectives. By the end of this lesson, students should be able to prepare amines, mention some physical properties of amines, and write some chemical reaction of amines. First, preparations of amines. Amines can be prepared from ammonia and alkyl halide. This is alkyl halide, RX. Alkyl means any carbon atom, and halide it means Cl, Br, or I. Here we have the ammonia. Now in this reaction, I have to replace this X, it means halogen, by NH2. This NH2 comes from NH3. Now, and we have NH4X as a side product. If you count this one, 2 times 3, we have 6 hydrogen atom. Here we have 2, and here we have 4. And here we have 2 nitrogen atom. So this is N, and this is another N. Example for this one, I replace alkyl group by CH3CH2. And I replace X by Cl. And this is ammonia. Now, the rule is just replace X, means Cl, by NH2. And you will get, this is ethyl and this is amine. And this is ammonium chloride as a side product. Now, this is the first method. But this method is limited in industry. Why? Because it leads production of mixture of amines and quaternary salts, which are difficult to separate them. That's why we add large amount of ammonia, maybe it is 70%. Why? To react completely with alkyl halide and stop the continuous reaction. Now, the second process, it is from reduction of nitro groups. Nitro group, it is NO2. Reduction, it means to add hydrogen instead of the oxygen. So, if you want to replace this oxygen by hydrogen, you have to use the reducing agent. Here we can use the active hydrogen. The active hydrogen, it is produced in the same reaction by adding active metal to the hydrochloric acid. Or you can use hydrogen in the presence of nickel as a catalyst. Or you can use another substance, we call it lithium aluminum hydride. In all of them, the same reaction. So what does it mean AR? It's aromatic compound or aryl group. You can use alkyl group, but this reaction is preferred for the aromatic compounds. Just only remove oxygen and replace it by hydrogen, so this is what you call it reduction. So nitro group is reduced to the amino group by any hydrogen or any process for this ones. Now this is example. I replace AR by the phenyl group, and this is NO2. This is, we call it nitrobenzene, because this is nitro group and this is a benzyl ring. You can write it another way, because this is C6H5NO2 also. Now by the reduction, use any factor from the previous ones, just replace oxygen by hydrogen. So this is amino nitro group is replaced by the amino group. Here we have nitrobenzene, we will get aniline. Now this is amine, and we remove 2H2O as a side product. In the exam, maybe the question is reduction of nitrobenzene gives aniline. So you have to memorize this formula or the word only. The another question, maybe reduction of nitro groups gives, so the answer is amino group. But if you have specific compound, you have to mention the specific name. So these are the two methods for preparing amines. Now we have to go to the next point, what you call it, the physical properties of the amines. Physical properties of the amines depends on the size of the amines. It means the molecular mass and also the type of amines, if it's primary, secondary, or tertiary. Here we have the first physical properties. Okay, the first member amines, methylamine or ethylamines, are gases. But by increasing the molecular mass, it means carbon atoms, so they change their states to liquid then to solid. That means the higher members of amines are solid. The second point, amines have the odor or the smell of the rotten fish. So when you smell the fish in the market, that means you smell the amines, because the fish or rotten fish produces different types of amines. So you have to remember this one. So this is the bad smell for the fish. They are amines, especially methylamines and ethylamine. Now the third point, the first member of amines are highly soluble in water and alkyl and ether. But the solubility decreases with the increasing of the molecular mass. So if the higher members, so they have less soluble in water. That means the higher member of amines are not soluble in water, so that means they don't dissolve in water. The second factor, not only the molecular mass, also the type of amines, as I said before. If we have primary amine or secondary amine or tertiary amine, primary amines, dissolve more than that of secondary amine and more than that of tertiary amine. Why? Because primary amines, have two hydrogen atoms attached to the nitrogen atom. So the primary amines make hydrogen bonds with water more than that of secondary amine, more than that of the tertiary amine. Now the fourth point is the boiling point. It's similar like the solubility depends on the type of amines and the size of the molecule. Here we have the boiling points of the primary amines more than secondary amine, more than tertiary amine. What is the reason? Because the primary amine have hydrogen bonds between their molecules more than secondary amine. But tertiary amine, there is no hydrogen bonds between their molecules, as there is no hydrogen atom, attached to the nitrogen atom in the tertiary amine. That's why the tertiary amines have the lowest boiling point. But in these cases, you have to focus on the size of the amines. They have to have the same, number of carbon atoms. Now, the boiling points also, if you have the same type of amine, so in this case, you have to compare, the molecular mass of the amine. So the one that has high molecular mass, so it has the higher boiling point. Now, this is example. The highest boiling point is for this compound, or this, or this, or this compound. You have to guess now. Just study first. You have to take which type of the amines. Now take the first one, the primary amine. Which are the primary amine, the secondary amine, and tertiary amine? Then you have to cancel the tertiary amine, then secondary amine, then you have to compare the primary amine if you have more than one. Now this is primary amine because you have NH2. This is secondary amine because you have NH. This is tertiary amine because there is no H attached to the nitrogen atom. Here we have primary amine again. Okay, so first cancel the tertiary amine because it has the lowest boiling point, then the secondary amine, and then we have the two primary amines. So the primary amines have the highest boiling point. Now, but this one, it has one carbon atom, and this has 3 carbon atom. In this case, I'm sure you get the answer. So what is the answer now? Yes, it is C3H7NH2 because it is primary amine and also it has the higher, molecular mass. Now this is the second one, it is the opposite. What is the lowest boiling point? you have first one, you have to know what is the type of amine and choose the tertiary amine. It has the lowest boiling point. Now which one now? This is primary, secondary, primary, and this is tertiary. So this is tertiary amine. It has the lowest boiling point. Okay, the least soluble compound in water for the same molecular mass is, it means you have the same molecular mass. So which one has the least solubility in water, or they have the least degree of dissolving in water? Primary amine, secondary amine, tertiary amine, or ammonium salt? What is the answer now? Yes, it is tertiary amine, because there is less hydrogen bond with water. So these are the points of the physical properties of amines. We have another points about the amines, the reaction of amines. In the amines, we have pair of electrons on the nitrogen atom. These free pair of electrons can be donated to another acceptor. So any substance has pair of electrons can be donated to another acceptor. We call them base. That's why amines are weak organic bases. When they dissolve in water, they give us OH. That's why they change, or turns litmus paper blue. Now, when they react with the acids. Why? Because amines are bases. So base react with acids. So this is as introduction for the reaction of amines. Now, the first reaction, it is with acidic solution. In the acidic solution, we write it as HX. Maybe it's hydrochloric acid, maybe it's hydrobromic acid, so any acid. So this is H and this is X. Now this is amine as primary amine or secondary amine or tertiary amine. So this is R, NH2. Now what is the rule? The pair of electrons on the nitrogen atom, joined with this hydrogen and give us NH3 plus, and here it is X minus. So X, it means chloride ions or bromide ion or any negative, radical. Here we have, this is the salt. We call it as the form of the salt. So this is the alkyl ammonium chloride or halide or bromide. If you want to extract this amine from its salt, amines are bases, but weak base. So you need strong base to extract it from its salt. So we have to add sodium hydroxide as a strong base. Now, in this reaction, the sodium atom takes X as NaX, and then we have OH takes one hydrogen atom as H2O. And we have now, so this amine, RNH2 like this one, so it is the same. Now, for example, this is example, I replace R by CH3. So this is CH3NH2 plus HCl. So X here it is Cl, and this is H, and this is NH2. What is the reaction now? NH2 takes this H and becomes, NH3 plus, and this is Cl minus. So this is what we call it, methyl ammonium chloride. This is salt. If you want to extract the amines from its salt, so you have to add NaOH. So Na takes Cl as NaCl, and then OH takes one hydrogen atom from here as H2O. So the amine, you get the amine again as it is here. So this is the first, reaction. The second reaction, amines also, because they are bases, they react with acid, the carboxylic acid or acid chloride or acid anhydride. So this is the example for the acid chloride. In this rule, this is RCO. CO, it means C double bond, or also Cl. And this is RNH2. You have to remove one hydrogen atom from the nitrogen atom with the Cl. Now, they are removed as HCl. What is the remaining here? The remaining from the first part is RCO. From the second part is NHR. You have to join, the compound from the same place that you cut it. So from here we have RCO, so this is RCO. In this case, you have to join with NH, not with R. Then NH, then go back. So this is NH, and HCl as a side product. For example here, CH3COCl, you have to follow the rule. What is the rule? You have to remove one hydrogen atom with Cl. Yes, they are removed as HCl. What is the remaining here? The remaining from the first compound is CH3CO. CH3CO. And from the second one, it is NHCH3. NHCH3. Don't write it CH3NH. No, from the same place that you cut it. Here we have another example with nitrous acid, and this is very important point in the exam also, because amines react with nitrous acid to give us the alcohol. You have to know the words only, not the reaction. Yes, we have alcohol. So alcohols can be prepared from amines by nitrous acid. And we have nitrogen gas. What is the reaction or the general rule of the reaction? You have to have primary amine. So this is primary amine, NH2. Reacts with nitrous acid, HNO2. You have to replace this nitrogen atom by the alcohol group, it is OH. Just remove NH2 and replace it by OH. Then R, it is the same. From where this is H2O and nitrogen gas. This N goes with this N as N2. Then this 2H with 1 O as H2O. What is the remaining here? We have OH. That's why I replace it here by the NH2. So this one is primary amine with nitrous acid give us alcohol. You have to memorize this point. Primary amines with nitrous acid give us alcohol. Now, this is example. This is ethylamine, C2H5NH2 with nitrous acid. Just you have to know it. Replace NH2 by OH, you will get ethanol, and this is nitrogen and the water as a side product. These are the reaction of amines. Now, the last point, why we study amines? What are the uses of amines? There are many uses of amines in our life. But in the book, we have only one use for this compound. It is CH2 by 6 NH2 NH2. We call it 1,6-diaminohexane. This compound, it is used in our life in the manufacture of the nylon fiber. But also we have another uses or another amine are used in our life, such as aniline. It is used in the family of the medicines or drugs in our life. To this point, we stop here for the amines, and thank you for listening for this lesson.